All right, go ahead and jot this original problem down in your notebooks. This is objective 21.3b. 21.3b. Again, write down this original problem in your notebooks. We're going to work this out very similar to what we've done before, only it's going to require a little bit of finesse. The very first thing that we're going to do, much like we do all the other problems, is we check to see if there is a greatest common factor other than 1. Is there something that I can divide 2y to the 5th by and 32z to the 4th to y by? You can divide by 2, but not only that, you can divide by also something else. Just a y, right? Not a y to the 2nd, but I can divide by a 2y. So that's what we'll do. To start off this problem is we'll divide each one of these by a 2y. What that does is it puts a 2y on the outside. And now what I want to figure out is what 2y to the 5th divided by 2y is. Well, 2 divided by 2 would give me 1. And I don't even really need to write the 1. And then y to the 5th divided by y to the 1. Remember, if we're dividing, we subtract our exponents. So 5 minus 1, y to the 4th power. Put a minus sign. And then we look to see. We have 32, z to the 4th, y. And we're going to divide that by 2y. Well, 32 divided by 2, there's 16. Z to the 4th, we have nothing really to put with it, so it's going to stay there. And then we have a y on top, y on bottom. What essentially happens on this part is that the y's will end up canceling out. You don't need to worry about the y being written. Close the parenthesis. What's tricky about this problem is that we gotta continue until we're entirely finished, and we're not done here. You may look at the fact that there are 2 terms and say, well, all the other problems that we've done in the past have 3 terms. Remember, we multiplied the first and the last term. We looked to see if they added to become the middle term. That isn't the case here. But what we're going to do is we're going to work this out much like we would if this was the first and this was the last and there was nothing in between. 0 in between. So, first things first, we're going to put together that box. Okay? Put the box right here. And much like we would in all the other problems, we're going to put the first term, top left-hand corner. Y to the 4th. Then we're going to put, bottom right-hand corner, negative 16, z to the 4th. And, again, much like all the other problems that we've done, we're going to put 2 lines down. We know we're going to be multiplying these 2 terms to equal the multiplication of both of these. That's negative 16 z to the 4th, y to the 4th. Negative 16 z to the 4th, y to the 4th power. And I want them to add to give me, well, hold on, there is no middle term, is there? We have the first and the last being written. What that essentially is saying is that there's nothing. 0. In other words, whatever terms I choose, they're going to have to cancel each other out. They're going to have to cancel each other out. In other words, they're going to have to be exactly the same, only opposite, right? 2 and negative 2, if added together, would give me 0. 6 and negative 6 added together would give me 0. Any ideas of what 2 numbers would multiply together to give me negative 16 that would add to give me 0? Yeah?
4 and negative 4.
It have to be, right? You tried 8 and negative 2, those wouldn't add to give me 0. But 4 and negative 4 works as far as the numbers go. But I have to consider a little bit more than just the numbers here, because I have that z to the 4th, y to the 4th. Okay? Well, it's going to have z involved in it, and it's going to have y involved in it. They're going to have to multiply to give me negative 16 z to the fourth, y to the fourth, but then add to give me 0. So they're both going to have the same number of terms. I have to be able to put them together. They have to be like terms. I'm going to give you this, and hopefully you'll be able to say, oh yeah, that makes sense. That's z squared, y squared. They both have to have a z squared, y squared. Again, they would multiply to give me negative 16 z to the fourth, y to the fourth, and if I added these two together, they would give me 0. 4z squared, y squared. This one's negative 4z squared, y squared. Okay, so those are the two terms, and it doesn't matter where I put them. I'll put the positive 4, z squared, y squared here, and the negative 4, z squared, y squared here. Okay, much like all the other problems, we are going to take the GCF of the first row. What's the biggest amount I can divide that first row by?
4.
I can't divide by 4.
I mean, 0.
I can divide by 1, but a little bit more than just 1.
2.
You mean y to the second power. I can divide by y to the second power. Just the y to the second, though. Or 1y to the second if you want to put that down. But remember, there's a 1 here, and I can't divide anything. I can't divide by anything other than 1, but I can divide by y squared. Now that I have that written there, I can fill out the rest of this. Y squared times what would give me y to the fourth power? Another y squared. Y squared times what would give me 4z squared, y squared? It's got to be a 4z squared because we already have the y squared. Then I have y squared again times what? That would give me negative 4z squared.
Negative 4.
Negative 4z squared. So far, I have it factored down to 2y on the outside. Then I have a y squared plus 4z squared. And then a y squared minus 4z squared. All right? Unfortunately, this isn't entirely done. And I have to tell you, the reason why is because of that y squared minus 4z squared that can actually continue to be factored down just one more time. This is one of those instances where you got to know, well, when do I stop? And it's anything that can be written as something squared minus something else squared. Notice the minus sign. You should be able to factor in this way. We are not going to worry about this one because it has a plus sign. The other one has a minus sign, and I know something is being squared here, it's y. And something else is being squared here, technically it's a 2z. This 2z times 2z would give me 4z squared. So it is factorable. There's more that we can do. And we're going to redo. Hopefully you've rewritten this already. We are going to redo another box with the y squared and the negative 4z squared. This will be the last box that we do right here. Hopefully this won't take us too long. Y squared here, negative 4z squared here. Two numbers that will multiply together. That would give me the multiplication of these two. That's negative 4z squared, y squared. And they would add, again, to give me 0. Any ideas what these two numbers might be? They got to multiply to give me negative 4, add to give me 0. Yeah, come.
Negative 4, 0.
Not quite. They get that wouldn't add. Okay, you're right. Actually, you're right. They would add to give me, and negative 4 and 0. They got to add to give me negative. They got to add to give me 0.
Oh.
Okay, and they would multiply to give me negative 4z squared y squared. Yeah. Negative 2 and 2. Okay, 2 and negative 2. That would multiply. 2 and negative 2. But be careful, we also have the z's and the y's that need to multiply. So in this case, it'll be zy, zy. Again, 2zy and a negative 2zy. In this case, they would multiply to give me negative 4z squared y squared, and they would add to give me 0. This is a multiplication right here, by the way, and the negative 2zy. Okay, so I'm going to put this down. Let's say we have 2zy here and a negative 2zy here. Again, we're going to factor out the top row. What's the GCF of that top row? Just the y. Can't take out more than that. And we know y times y is y squared. Y times 2z would give me 2zy. And y times negative 2z would give me negative 2zy. So factored out just one more time, this last piece, that's going to be our final answer, is the 2y that we originally factored out at the very beginning. Then we have the part that we ignored with the plus sign. Y squared plus 4z squared. And this part, which we just got done factoring using this box, is y plus 2z in parentheses times y minus 2z. Definitely a problem that was a little tricky. It continued to be factored all the way down. We had a lot involved here. We had the GCF. We had 2 different boxes. And we had that middle term. You're going to notice in this section, in this objective, that middle term is actually